Hey guys, my name is George, and in this video, I'm going to show you how to convert a repeating decimal to a fraction. So let's start with the repeating decimal 0.34 repeated. And we want to go from here, from this repeating decimal, to a fraction of the form of p over q, where both p and q are integers. Okay. So how do we do this? First of all, this line up here shows us that 34 is repeating indefinitely. So I can also represent this as 0.34, 34, 34, and this goes on and on. And this line up here is also called vinculum. Okay. And how do we approach this? So how do we go from this repeating decimal to something of this form? Well, I can set up an equation. I can say let x be equal to 0.34 repeated, which, as we stated up here, is also equal to 0.34, oops, 0.34, 34. I'm going to skip the third one, but it keeps going. And so now, this is the first equation that I have, and we're going to reference this later. Now, what I'm going to do next is I'm going to multiply my x, or the left-hand side of this equation, by 10 to the power of a positive integer. So let's say we have 10 times x. And then also, over here, I'm going to add a certain power. And depending on how many repeating numbers are in this repeating decimal, for example, here we have two repeating numbers. So this 10 would be raised to the power of 2, because over here there are two repeating numbers. If there was only one repeating number, I would have raised this 10 to the power of 1, which is 10 to the power of 1 is just 10. If there were three repeating decimals, or three repeating numbers in this decimal, I would have raised this to the power of 3. So that's how it works. So far I've multiplied x by 10 to the power of 2, which is 100. Now, since I have multiplied the left-hand side by this number, to maintain this equality sign, I need to multiply the right-hand side as well. And that means that I'm going to multiply the repeating decimal. I'm going to use this form for ease. So 10 to the power of 2, or 10 to the power of 2 is multiplied by 0.3434. And we can solve here, right? So we can also represent 100 as, or sorry, 10 to the power of 2 as 100, right? So let's solve this. So 100x is equal to, and now 100 times, oh, forgot my 3 dots here, which means that this just keeps repeating indefinitely. So 100 times this decimal here, let's move some decimal points. If we multiply this decimal point is going to move 2 places to the right, and this decimal point, which is technically here, is going to move over here. So then we get 1 times 34.343434 repeating, right? Which is 34.34 34 repeating. Okay, so now we have this second equation over here. Now, I'm not going to go ahead and keep solving, because if I do, I'm going to go back to, okay, x is equal to 34 by 34 divided by 100, which is, and we come back to this form up here. So instead, what I'm going to do is I'm going to bring this equation that we had up there down here, and I'm going to subtract the second equation from this first equation. So 100x, and then make sure that you keep what's on the left-hand side underneath what's on the left-hand side of the equation up here. So then we have 100x minus x, which is equal to 34.34 repeated. And on the bottom here, minus x, which is equal to 0.3434 repeated. And actually over here, you can add another 34, just so that they cancel out, right? And so here's how we do this. We're going to subtract the top, or from the top left-hand side, whatever we have on the bottom left-hand side. So 100x minus x is equal to 99x, which is equal to 34 times 34 repeated, well, minus 0.34 repeated. So this over here is going to cancel out, and we're going to be left only with this 34 without the rest, right? And at this point, we have this equation which we can solve for x, and I'm going to move it up here. So then we have 99x is equal to 34. How do we solve this? Well, we want to isolate the x, right? So we want to get rid of this 99. How do we do it? Well, let's divide by 99. If we divide the left-hand side by 99, we need to divide the right-hand side by 99 to maintain this equality sign here. So 34 divided by 99. 99's here cancel out, and we are left with x is equal to 34 over 99. Okay, and so now that we have what x is equal to in the form of p over q, where both numbers are integers in the numerator and the denominator, we come back here and see, oh, okay, so we can just substitute what we have for x here into here, because remember, x is equal to 0.34 repeated, and so we get that 0.34 repeated is equal to 34 over 99. Okay, and you can finally double check this in your calculator if you have one handy. Yep, we got it right. Thanks for watching.